All right, here we go. We're on number 11. Number 11 says to write an equation of a line that is parallel to y equals negative 3/5 x minus 7 and has a y-intercept of 2/5. And we want to make sure we write it in standard form. Write it in standard form. All right, so this is the equation that we're working on. Here's what we know. In order to have lines parallel to each other, the only way that's going to happen is if the slopes are exactly the same. So when I write my equation, I'm going to need to use the same slope as this equation here. So the question is, what's the slope of that line? Negative 3/5, negative 3/5. So my equation, we're going to have negative 3/5. We're also going to have a y-intercept of 2/5. All right. The y-intercept has to be 2/5. So notice here that I have a slope and I also have a y-intercept. So since I have a slope and a y-intercept, it would only make sense to write an equation in slope-intercept form. So negative 3/5 is going to be my slope. 2/5 is going to be my y-intercept. So there's my equation. However, that's not the answer. And that's because they asked us to write the equation in standard form. And right now I don't have the standard form. So I'm going to move some things around so that I do have standard form. And for those of you that don't remember what standard form is, it's ax plus by equals c. That is your standard form. So that's what we're trying to get to from that y equals negative 3/5 x plus 2/5. So the first thing I'm going to do is move that negative 3/5 x over to the left-hand side. So now it becomes a positive 3/5 x plus y equals 2/5. We're getting closer. However, I got one small problem. Fraction. We can't have fractions. So we're going to fix that problem real quick here. We're going to take that thing, and we're just going to multiply it by a 5. Where did I get the 5 from? It's the denominator. So if I multiply this out, I end up with 3x. 5 times y is 5y. And 5 times 2/5 is 2. And now I've got my standard form. And that is your standard form. So there's your answer to number 11. Number 11. Get that. All right, let's move on to the next one, number 12. Number 12 says, what is the y-intercept of a line that runs perpendicular to the given line and passes through the points to the point 13,7? First thing I'm going to do is start off with the equation of this line that we're given. I want to know what's the equation of that line. Now, the easiest way to find the equation of that line is to use our stat button. After all, they did give us 2 points. We got the point 1017, and we also got the point 63. So do a linear regression for me and see what we get for the equation. Linear regression. All right, what did you get from the linear regression? What were the two numbers? 3.5 and negative 18. However, we're not going to use the 3.5. The slope is defined as rise over run. We're going to write it as a fraction. So 3.5 is the same thing as 7 over 2. And you can use your math button to get that. All right, so we have the equation y equals 7 over 2x minus 18. That is the equation for this line that we're given. But what we're going to do is we're going to write one that runs perpendicular to that line and also goes to the point 13.7. So here's what we know about perpendicular lines. The only way lines can be perpendicular is if we have opposite reciprocals. So what I'm about to do is that 7 over 2 is flip it upside down. That's reciprocal. And I'm also going to have to change the sign. It's got to be opposite. So my slope is going to be negative 2 over 7. That is the opposite reciprocal of 7 over 2. Not only does it have to have a slope of negative 2 over 7, but it also has to go through the point 13.7. Got to meet both of those requirements. So notice what I have here. I've got a slope, and I've also got a point. Slope, point, which means I've got to use the point slope form. This is the point slope form. We worked with this one the other day. That's the point slope form. I'm going to take some of those letters out and replace it with some numbers. The y1 is going to be replaced with the y value, which in our case is 7. M is going to be replaced with the slope, negative 2 over 7. And the x is going to be replaced with 13. All right. Now I'm going to go ahead and use some distributive property. Negative 2 over 7 times x is a negative 2 over 7x. Negative 2 over 7 times a negative 13 is a positive something. Put that in your calculator and let's find out what that is. Negative 2 over 7 times negative 13. And I want the fraction. Make sure you give me the fraction. Negative 2 over 7 times negative 13. 26 over 7. 26 over 7. Now notice what I'm trying to do here. I'm trying to get this thing in slope-intercept form. So the next thing I'm going to do is add 7. So again, with your calculator, let's add 26 over 7 plus 7. Remember, you can put fractions in your calculator. 26 over 7. Green button, y equals 25 over 7. So we get the equation y equals negative 2 over 7x plus 25 over 7. This is the equation that runs perpendicular to this and also goes to the point 13.7. But let's make sure we've actually answered the question. The question was, what is the y-intercept of that line? What is the y-intercept of that line? That was the question. So what is the y-intercept of that line? It's right there. The y-intercept of that line is 25 over 7. And there you have your solution to number 12. A little tricky on that. All right, we're going to move on to number 13. Number 13, they ask us to write an equation of a line that is parallel to 2x minus 4y equals negative 6, and also goes through the origin. Write the answer in slope-intercept form. All right, so here we go. It's got to be parallel to 2x minus 4y equals negative 6. And the only way my lines can be parallel is if they have the same slope. So the first thing I'm going to do is get this thing in slope-intercept form. So I'm going to start. I'm going to start by moving the x to the other side. Negative 2x minus 6. Next thing I'm going to do is divide by negative 4. Then I'm going to come over here and reduce these fractions. Negative 2 divided by negative 4 reduces down to a half. A negative 6 divided by a negative 4. What's a negative 6 divided by a negative 4 reduced to? Positive. Okay, but give me the fraction. Use the math button. 3 over 2. All right, so this right here is the equation in slope-intercept form. Now, why did I need that? Because I needed the slope. That slope is important. The only way my line is going to be parallel to this line is if I have a slope of 1/2. Now, notice there it says it's going to go through the origin. It's going to go through the origin. Well, if that's true, we're going to have a y-intercept of 0. If it's going through the origin, we have to have a y-intercept of 0. So, I have a slope. I have a y-intercept, which means I can write the equation in slope-intercept form. And that equation is y equals 1/2 x plus 0. Do I really need to put the plus 0 back there? No. And there's the equation. This is an equation of a line that runs parallel to 2x minus 4y equals negative 6, and it also goes through the origin. All right, let's go to number 14. The solutions to the inequality y is less than negative 3 falls in which quadrant? Which quadrant? Well, let's take a look here. This is the graph. If I want to graph the inequality y is less than a negative 3. Notice there's no x in that problem. And because there is no x in the problem, we're going to end up with a horizontal line. In this case, that horizontal line is going to go right through the negative 3. Notice there's no equal sign, which means my horizontal line is going to be a dotted line. And because it says less than, I need to shade in which direction, the top or the bottom? Less than. Top or bottom? Bottom. We're going to shade to the bottom. This is where all the solutions are at. That's what the graph of y is less than 3 looks like. So the question is the solutions. Which quadrants are they in? Where are all the answers at, guys? In quadrant 1, 2, 3, or 4? 3 and 4. So out to the side, we're going to put there in quadrants 3 and 4. Quadrants 3 and 4. All right, so that's number 14. Let's do one more, number 15. Number 15 says, consider the quadratic parent function. What would the equation for the family member be resulting from translating 2 units to the right and 5 units down and a vertical stretch by a factor of 4? Well, let's start with the parent function. This right here is the parent function. And I'm going to do a couple of things to it. Let's see here. First of all, it says we're going to translate this thing 2 units to the right. 2 units to the right. I've still got all the transformations over here on the board. So if you don't remember the transformation, you can look over here. If I want to move to the right, what do I have to do? To move to the right. Subtract, in our case, how many? Right. It says we're going to translate 2 units to the right. So it's minus 2. Taking 2 away from the x. Notice it's inside the parentheses. Now what I want to do is I want to move 5 units down. 5 units down. What does it say over there if I want to move 5 units down? Subtract. I'm going to subtract 5, but again, notice it's on the outside. That's going to move it down. We're also going to have a vertical stretch by a factor of 4. I want to stretch it out. So we're going to need to multiply the function by 4. So this is the equation that has all of those transformations to its parent function. Minus 2 moves it to the right. Minus 5 moves it down 5. And the 4 is going to stretch it vertically. All right, so that takes us through number 15.